Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this video, I will discuss the topic of S1, that is about measures of spread of data. So once you have found out the measures of central tendency like mean, median and mode, that's basically a single value about which your data is scattered. But as far as measure of spread is concerned, that tells you about the scatter of the data. Basically, this tells you about how much you can rely on the data. A data with a larger scatter is less reliable and data with a smaller scatter is more reliable. If you will take this example of a data which is 0, 50 and 100 and you will find out its average value, that comes out to be 50. And you will also consider this another data which is 49, 50 and 51 and you will calculate its mean value by adding them and divide by 3. That also comes out to be 50. Both of these data have exactly same measure of central tendency, that is mean. But if you see, one data is less scattered and the other data is more scattered. So we determine this measure of scatter of data by the measures of spread of data. And of course, the data that has a lesser scatter is supposed to be more reliable as compared with the one which has a greater scatter. So you can consider this as like the 3 consecutive score of one batsman and 3 consecutive scores of the other batsman. Then you can clearly see that this batsman has good scores, but that is less reliable as compared to the batsmen whose scores are 49, 50 and 51. So that's like a more consistent batter as compared to the other one. So the examples that we have of the measures of spread, one of them is the range. So what we do is that the largest value minus the smallest value. So you can see that for this data, the range comes out to be 100. And for this data, the range comes out to be 51 minus 49 and that will be 2. So a smaller range means less scatter and less scatter means more reliable data. Now, basically what can happen is that your data may have an outlier, that is an outlier value on the upper tail or on the lower tail. Like your data has been like pretty consistent with let's say 34, 37, 39, 33, 32, something of that kind. But then your data has something which is really big or really small. Like one data could probably be 1 and one data could probably be 75. So these are your outliers and these values may probably be the values which may have some sort of error. And if you want to avoid your outliers, then instead of going for the range, you can go for interquartile range. So interquartile range gives you the difference of 2 data. One is the lower quartile and the other one is the upper quartile. Lower quartile lies at the 25% position of your data and the upper quartile lies at the 75% position of the data. So you will see what data is at 1/4 of the total location and then you will see what data is 3/4 of the total location and you will find those data values and minus those data values and you will get yourself the interquartile range. So this is a little more tiring process, but this is helpful because it gets rid of the outliers in your data. So to find out the lower quartile and upper quartile, you need to know the position of the lower quartile as well as the position of the upper quartile. The position of the lower quartile is 1/4 of the total frequency plus 1. So if you have a number of data, you do n plus 1 upon 4. And if you have total frequency, then you do sigma f plus 1 upon 4. And if you are finding out the position of the upper quartile, that will be 3/4 of n plus 1 or 3/4 of sigma f plus 1. Now, when you apply this formula, there could be a possibility that you might get an integer value and that will be directly the location that you'd search for. Like if you get a position as 3 and you get a position as 14, then you will look at the data at the 3rd position and you look at the data at the 14th position and you just minus them up and you will get yourself the interquartile range. But sometimes what may happen is that it might come out to be a decimal, like let's say you get a position as 3.5. the possibility of decimal is only either 0.5 because you're dividing it by 4, so it could only be either 0.5 or 0.25 or 0.75. So if you get a 0.5, then you will look at the data which is at third and fourth location and average those two data values out. If you get an integer value, that will be the data that you'd look for. If it's a 0.5, then you would look at the data at the third position and the fourth position and average them out. And if you get something like 0.25 or 0.75, then just round them off. So 3.25 means you just consider the third location, and a 3.75 means that you would just consider the fourth location. The other measure of spread that you should be able to calculate is standard deviation, and you calculate standard deviation through variance. So basically what standard deviation is that if you have a set of data and that data is scattered about a particular point and you have one mean value, that is x bar, then what you see is that how much is the average deviations of the data from the mean value on both sides. So you will find out the deviations, but there's a little problem with the deviations because some data would be above the mean value and some data would be below the mean value. So when you will try and find out the deviations, few of them would be positive and few of them would be negative. So if you directly average out these deviations, you'll always get an answer that is close to 0. So what you do is that first you find out the deviations, then you square them up. Once you square them up, then all of the values will become positive and you calculate their mean. But then you will not forget that you have found the average of square of deviations. So finally, to account for that, you put a square root onto that. And maybe in some other video I can explain you why, but somehow this formula can also be simplified into this form. So this is a more direct way of calculating the standard deviation, which actually comes from this formula by opening this square up. So if you want to use this formula, you can use this, or you can use this formula as well, which is sigma x square upon n minus x bar square. Both formulas are going to be provided to you in the formula sheet, and these are only for raw data. So in case if you have a frequency table, then your formula changes a bit. It will be deviations square multiplied by their corresponding frequencies being summed up, divided by sigma f. So it's sigma f x minus x bar whole square divided by sigma f, or you can also use the direct formula for this, which is sigma fx square over sigma f minus x bar square. So if you have the standard deviation and you take a square of it, then that is called the variance. So sometimes you could be required to find out the variance, and sometimes you'd be using the standard deviation. What you must know is that variance is just the square of the standard deviation. So if in this formula, if you don't put a square root, then what you get is a variance. And after putting a square root, you will get yourself the standard deviation. Let's have a look at a few examples here. I've been given a data. Let's say I had to find the range. I look at the biggest value, I look at the smallest value, I minus them up, and I'll get myself the range. But if I have to find out the interquartile range, I'll first find the position of the lower quartile. There are 9 sets of data over here. 9 plus 1 over 4 gets me 2.5. So I have to look at second and third location. And second and third location, I have both 3's, an average of 3 would be 3. So my lower quartile is going to be 3. To find the position of the upper quartile, I do n plus 1 into 3 upon 4. That comes out to be 7.5. So that means I have to look at 7th and 8th location. So when I look at 7th location, I have 11. And when I look at 8th location, I have 15. So it's going to be the average of 11 and 15. That comes out to be 13. So my lower quartile is 3. My upper quartile is 13. But also please remember, every time you're finding out the interquartile range, you make sure that you have put the data in the order. It should not be a randomly stated data. It has to be in ascending order. So once you have data being arranged, if it is not arranged, then first thing you should do, whether you're finding median or interquartile range, since position of data matters, you have to arrange it in an ascending order. So once you have the upper quartile, you have the lower quartile, you minus them and you will get yourself the interquartile range. Then if let's say you have to find out the standard deviation, there are 2 ways you can find out the standard deviation. But for both of the methods, you need to know the mean. So what you do is that you add all of these values, divide by 9, and you'll know the mean. So if you apply the first formula of the standard deviation is under root sigma x minus x bar whole square over n. So what I do is that from every value of data, I'll subtract mean and then I'll square it and I'll add them up. So these are the deviations square being added divided by number of data. That gives me mean of deviation square, and then I'll take the square root of that and I'll get the standard deviation. Alternately, I could also use this formula in this form, where what I'm going to do is that I'm going to do sigma x square, and sigma x square would be 1 square plus 3 square and so on and so forth till 17 square divided by number of data, which is 9, and minus x bar square, that will be 7.889 square. This also gives me the right answer, so I can use this method or I can use this method. Definitely this is a more easier way of doing it because you don't have to subtract mean from every value. You can also have data in the form of a frequency table, and you could be asked to find out the interquartile range, and you could also be asked to find out the standard deviation. So once you add up all the frequencies, that comes out to be 53, and when you do 54 upon 4, you get 13.5. So that means you're looking for 13th and 14th location. Similarly, when you do 54 into 3 by 4, you get 40.5. So that means you're looking for 40th and 41st location. Now, this data is already arranged. So you have first 5 locations 1, you have next 7 locations 2, you have next 12 locations 3. So you know these are the cumulative frequencies. So first 5 location you have 1, then 6th to 12th location you have 2, and 13th to 24th location you have 3. So I can see that 13th and 14th location both will have 3 onto it, and the average of 3 and 3 would be equal to 3. So my lower quartile would be 3. Similarly, if I look at 40th and 41st location, up to 39th location I have 4, and from 40th to 48th location I have 5. So that means both 40 and 41st location would be occupied by 5. So two fives would average up to again 5, and my upper quartile would be 5 as well. And I can now find out the interquartile range by subtracting the upper quartile and the lower quartile. To find standard deviation, I need to know the mean, and for mean I need to find out a column of fx. So this is my column of fx, and I will add them up. I will get the sigma fx divided by sigma f, and that will get me the mean value. I will also make another column of f into x minus x bar square. So that means from x I will keep on subtracting mean value, and then I'm going to square it, and then I'm going to multiply it by frequency f. So for the first one, I'm going to do 1 minus mean, that is 3.623 square, multiplied by the frequency, which is 5. Similarly, for the second one, I'm going to do 2 minus 3.623 whole square times its own frequency, which is 7. So I keep on doing that, and I'll build up a column of f into x minus x bar whole square. And once I add all of these values at the bottom of the table, I'll get sigma f into x minus x bar whole square. So this divided by sigma f, which is 53, will get me variance, and when I'll take a square root of that, I'll get the standard deviation. Other possible way of calculating the standard deviation out of the frequency table could be that I make a column of fx square. Fx square would be, and this is the direct way, 5 into 1 square, 7 into 2 square, 15 into 3 square, and once I've built up all of these values, I can find myself sigma fx square. So the other formula that I have is sigma fx square over sigma f, and mean was already sigma fx over sigma f. So 196 over 54 gets me the mean value, and then sigma fx square, which is 840 divided by sigma f 54 minus mean square, and square root of that will directly get me the standard deviation. So guys, there could be questions where you have the data being provided in a specific way, and you have to use that specific way to calculate what's required. Like you have to calculate the mean and standard deviation of the scrub with sigma x square and sigma x being known to you. So for mean, you will use sigma x over n. This is for 18 people, you'll get the mean, and then sigma x square over n minus x bar square square rooted will give you the standard deviation. But another part of the question, it says that one of the person leaves the group, mean age is 17, of the remaining 17 people is 41. find the age of the person who left. So I know that since x bar is sigma x over n, then sigma x would be x bar into n. So I have the average age of people, which is 41. 41 times 17 will give me their summation, and I had the previous summation, which is 745. So when I subtract these, I will get myself the age of that person who left. And then we also have to find out the standard deviation of the ages of the remaining 17 people. We have the sum of squares of the original data. If I'll do minus 48 square from that, I will get the new sigma x square divided by n minus x bar square, and I'll get myself the standard deviation after square rooting that. If you have data in the form of group, then you, in place of x, what you do is that you use the mean value of the upper bound and the lower bound. So that'll be 5, 15, the average of 0 and 10 will be 5, the average of 10 and 20 will be 15, average of 20 and 40 would be 30, and 40 and 80 would be 60. So sigma fx will be 2 times 5, and 15f, 11 times 30, and 4 times 60. Since you knew the mean, you can apply the mean formula, and the unknown frequency can be calculated by making an algebraic equation. And once you get the frequency, you can get another column of fx square and then use that to calculate the standard deviation, sigma fx square over sigma f minus x bar square. So guys, I hope this video helped you towards understanding what is the purpose of calculating the measures of spread, and how do we calculate the measures of spread, specifically talking about how do we get ourselves the range, the interquartile range, and the standard deviation. If this video helped you, I would really appreciate if you'd give a thumbs up and also subscribe to my channel. Thank you.